Team, we have a major crisis here. Our local campus just rejected our entire weekly supply from Dutchmen. They say it's flat, won't form for letters, and it tastes like watered down clouds.
Can we just pour a little bit into our coffee, taste it ourselves, says it tastes fine, and go watch a movie? I don't see why this requires a whole team meeting.
Absolutely not. We promise to help investigate using the real analytical proof.
Inspector, let's look back and see. I swear the limit is 100% premium, rich in calcium, and fresh from the farm. No, that water was added to cheat the volume.
We don't rely on promise here, Diana. We rely on data. Okay, Irfan. So what is our plan? Can we just use a quick color test or dip a piece of paper in it?
Can you give me one of that, please? A quick color indicator strip might give us a rough guess, but colors can be misinterpreted, and the test strips expire. To get undeniable absolute proof that holds up in a court, we must use the ultimate method of analytical chemistry, which is gravimetric analysis.
Gravimetric sounds like a heavy metal band or a sci-fi gravity weapon.
It's much more logical than that. Gravity means weighing and metric means measuring. It's a quantitative method where we take our target analyte, the hidden disulfide ions inside the silicate mud, and chemically force them to clump together into an insoluble solid powder. Then we physically separate the powder and weigh it on a scale because weight is an absolute physical property that data doesn't lie.
The solid powder is a medical meal.
Okay, sounds cool. But how do you physically pull invisible calcium out of a liquid without a $1 million laboratory? Do we squeeze the mud through an old t-shirt?
If you just squeeze raw mud through a close, you get nothing but a messy cloud fabric. True gravimetric analysis follows an exact 8-step logical sequence. Farzana, grab a pen. We are going to walk through them right here at this kitchen table.
Alright, hit me with the play-by-play.
Step 1. Preparation of sample solution. In our lab, we will meticulously adjust the environment here, controlling the total volume, the temperature, and the pH.
Wait. Why do we care about adjusting pH and temperature in a cup of milk?
Because if the solution conditions are not perfect, our target calcium might still dissolve and invisible. Or worse, either our particle will try to crash to the BINTI and settle down with it. We want a perfectly adjusted environment to prevent poor precipitation impurities from messing up our final rate.
I see.
Excellent. Now for the chemical reaction. Step 2. Precipitation.
Watch closely. We add our reagent slowly and stir effectively. Ideally, we want the solution to be warm and dilute.
Wait, why slow and warm? If you dump it all in fast, won't it finish quicker?
If you dump it in fast, you cause instant nucleation, like millions of microscopic tiny cloud particles that form a messy suspension. They are so small, they will slip right through any filter. By keeping it warm and adding it slowly, we favor particle flow. The crystals grow larger and horizontal, making them easy to catch.
I understand now.
Don't forget step 3, Irfan. The secret wedding game. Digestion.
Digestion means letting the solid sit in the hot liquid for a while. It allows the tiny unstable particles to resolve and recrystallize onto the larger, sturdier crystal. It purifies our solid and expel trapped impurities.
Okay. Wrap, precipitation, and let it digest. What's next?
Step 4. Filtration.
Step 5. Washing.
We pour our mixture right through. The liquid flows to the bottom, but our pure calcium crystals are trapped perfectly on top of the paper. Then, we wash the solid with a little bit of cold water to rinse away any lingering messy liquid sticking to it.
Wait a minute. Your paper is weak. Water has weak. Your whole experiment is rigged.
Nah, nice try, Diana. But we are 3 steps ahead of you. Fazana, can you read the next step of from your paper?
Let's see. Step 6, drying.
Step 7, cooling and waiting.
We place our trapped solid inside a high temperature oven to completely evaporate every single drop of moisture. But once it comes out of the heat, we can't just leave it on the open counter to cool down.
Why not? Food cools down on counters all the time.
Because a complete dry chemical solid acts like a sponge for humidity. It will immediately absorb moisture right out of the room bag and draining better water away.
So we place it inside this desiccator, which protects it while it cools down to room temperature so it stays 100% dry.
And now, the moment of absolute reckoning. Step 8. Calculation. Farzana, place the dry cooled sample onto our scale.
The scale reads 2.5 grams.
Hold on. In real analytical science, we must repeat the heating, cooling, and weighing cycle until we achieve a constant mass. The rules state that the difference between the two consecutive weighings must be no more than 0.002 grams. Okay, now it reads 2.4999 grams. Constant mass achieved.
Awesome! So we have exactly 2.499 grams of pure calcium?
Not quite. The solid on that scale isn't pure calcium, it's a chemical compound containing calcium combined with our reagent. To find the actual weight of our pure analyte, we must apply the mathematical key, gravimetric factor aka GF.
Oh no, man! My ultimate high school enemy.
Just a simple ratio. The gravimetric factor is the formula weight of what we want. The calcium analyte divided by the formula weight of the entire precipitate compound we just weighed. We multiply the weight from our scale by this factor and it reveals the exact grams of pure calcium present. Then, we divide that by the original mass of the mode sample to get our final percentage.
Alright. The math is finished. According to the DANIYAL law of conservation of mass, this milk sample contains staggeringly 45% less calcium than conventional one.
No, this is ridiculous. Your kitchen scale is broken. Your coffee filter is biased.
You can argue with mass, Diana. This method doesn't rely on electronic sensors or digital gadgets that can be tuned. We physically isolated to solid content and half of your calcium is completely missing.
Wow, so you actually diluted the milk jugs with tap water and extra money, didn't you?
Alright, I confess. I added 20 gallons of tap water on Tuesday morning. I thought nobody would ever notice a slight drop in calcium. I would have gotten away with it if it were not for you medical student and your incredibly accurate laws of mass conservation.
Case closed. Take this milk away. Excellent work, team. Gravimetric analysis saved the day without us ever stepping foot inside the high-tech facility.
It's amazing how this same principle is used worldwide. Environmental group use it to filter and weigh solid pollution in river water, and manufacturing plants use it to test the purity of consumer goods.
Exactly, because you are either professional lab or just in a kitchen counter, the science mass remains absolute.
Hey Inspector, since we cracked the great milk case, can I finally go eat my lunch?
Yes, Farzana, go eat. But remember, if you ever want to discover the absolute truth, you just have to wait it out.